In the middle of May 15, 2024, our planet experienced the most powerful solar storm in over 2 decades. This impressive event was a direct result of the Sun's increasing activity as it approaches the peak of its current solar cycle. The solar storm was so intense that it created stunning auroras, lighting up the night sky and dancing across the horizon at much lower latitudes than we typically see. You might be wondering about the details of this celestial event. What exactly happened? Are solar storms something we should worry about? How did this storm impact Earth? And can the space agencies predict such space weather phenomena? Let's dive into these questions to uncover the fascinating details behind this natural spectacle and understand its implications. Solar storms, also known as geomagnetic storms, occur when the Sun releases a significant amount of solar wind and magnetic fields. These particles travel through space and interact with Earth's magnetic field, causing disruptions that can affect satellite communications, power grids, and even navigation systems. Despite these potential dangers, solar storms also create one of nature's most beautiful displays, the aurora borealis and aurora australis, commonly known as the northern and southern lights. During this recent storm, the auroras were visible far beyond their usual polar regions, enchanting people in locations where such sights are rare. This not only provided a breathtaking visual experience but also sparked curiosity and questions about the nature of solar storms and their effects on our planet. The European Space Agency, named ESA, plays a crucial role in monitoring space weather and predicting solar storms. By studying the Sun's activity and using advanced technology, scientists can forecast these events and help mitigate their impact on Earth. This predictive capability is essential for protecting our technological infrastructure and ensuring that we can continue to enjoy the awe-inspiring beauty of auroras without unnecessary fear. The solar storm of May 2024 was a remarkable event that showcased the dynamic relationship between the Sun and Earth. While solar storms can pose certain risks, they also offer a unique opportunity to witness the mesmerizing dance of auroras. With the efforts of organizations like the ESA, we can stay informed and prepared for these extraordinary occurrences, appreciating both their scientific significance and their natural beauty. What happened? Space weather, originating from activity on the Sun's surface, extends across the entire solar system. In this case, a particularly large and active region of the Sun, which was directly facing Earth, erupted multiple times, sending a massive solar storm our way. These eruptions consisted of several powerful solar flares and a series of coronal mass ejections, named CME. The CME propelled vast amounts of fast-moving, magnetized plasma through space, directly towards Earth. Our planet's magnetic field usually serves as a robust shield against such solar events. However, this time, the sheer intensity of the storm stretched and stressed our magnetic protective layer to an extraordinary degree. As a result, charged particles from the Sun collided with Earth's atmosphere, producing stunning auroras. These mesmerizing light displays, typically confined to the polar regions, were visible much further south, enchanting people in regions that rarely witness such phenomena. This solar storm not only highlighted the power and unpredictability of space weather but also raised awareness about its potential impacts on our planet. For instance, intense solar activity can disrupt satellite communications, interfere with navigation systems, and even affect power grids. Understanding these risks underscores the importance of monitoring the Sun's behavior and developing strategies to mitigate the effects of solar storms. In this way, this recent solar storm was a vivid reminder of the dynamic relationship between the Sun and Earth. It showcased the beauty of auroras while also emphasizing the need for continued vigilance and preparedness in the face of space weather. Why was this storm so big? The size and intensity of solar storms depend largely on the Sun's position within its 11-year solar cycle, which fluctuates between periods of high and low activity. We are currently approaching the peak, or solar maximum, of the current cycle, a time when large solar storms become more frequent. For the past 5 years, the Sun has been progressively twisting and contorting its magnetic field. As we near the solar maximum, this magnetic field becomes highly entangled and unstable. Imagine stretching an elastic band to its limit. Similarly, the Sun's magnetic field can snap when it becomes too stressed. When this happens, it releases massive amounts of plasma at high speeds, along with electromagnetic radiation and high-energy particles. This process is a result of the sun's dynamic behavior. During the solar maximum, the increased magnetic activity leads to more frequent and powerful solar flares and coronal mass ejections. These events send fast-moving magnetized plasma hurtling through space, which can impact Earth if directed towards our planet. The recent storm was particularly significant because it originated from a very active region of the Sun. This region faced Earth and erupted multiple times, unleashing a barrage of solar flares and CMEs. The magnetic field lines, having become extremely twisted and strained, snapped and released a huge volume of plasma and energy. Understanding why this storm was so large helps us appreciate the intricate and powerful forces at play within our solar system. It also underscores the importance of monitoring solar activity, especially as we approach periods of heightened activity. By keeping a close eye on the Sun, scientists can better predict and prepare for the impacts of such formidable space weather events on our technology and daily lives. Are such big solar storms dangerous? Major space weather disturbances, like large solar storms, are not directly dangerous to people on Earth's surface because we are protected by our planet's magnetic field and atmosphere. These natural shields prevent harmful solar particles and radiation from reaching us. However, some geomagnetic storms can bring energetic particles that pose limited risks to high-altitude and high-latitude flights. To mitigate these risks, flight paths may be adjusted to avoid potential communication and navigation issues or unnecessary radiation exposure. For astronauts, who operate outside the protective layers of our atmosphere, and for future lunar explorers who may also be beyond our magnetic field's protection, timely warnings of incoming space weather are crucial. These warnings allow them to take necessary precautions to ensure their safety. Solar storms can also have significant impacts on technology. Our Sun's outbursts have the potential to disrupt and damage satellites, affecting essential services such as GPS navigation, telecommunications, and weather forecasting. Additionally, these storms can interfere with power grids on the ground, potentially causing widespread outages and affecting everyday activities. Critical infrastructure, including banking systems that rely on satellite communications, can also be vulnerable to these solar events. Timely and accurate space weather forecasts are essential for protecting both astronauts and vital infrastructure. By monitoring the Sun's activity and issuing warnings, scientists and engineers can take steps to safeguard satellites and ground-based systems, minimizing the potential disruptions caused by solar storms. In summary, while large solar storms do not pose a direct threat to people on the ground, they can affect high-altitude flights, astronauts, satellites, and critical infrastructure. Understanding and preparing for these events is essential to mitigate their impact on our technology-dependent world. Did we see this storm coming? Large solar storms are more frequent as we approach the solar maximum, and while we can predict the likelihood of such eruptions, pinpointing the exact timing and intensity remains a challenge. The analogy of an elastic band snapping illustrates the difficulty in forecasting the precise moment of these solar events. Despite these challenges, the Sun's active regions are under constant surveillance. The European Space Agency utilizes a range of space weather services to monitor solar activity. These services are crucial for industries and spacecraft operators, enabling them to respond swiftly to space weather events. When the recent solar storm erupted, its effects were meticulously tracked as they journeyed towards Earth. Solar flares, which consist of electromagnetic waves traveling at the speed of light, reach us almost instantaneously, leaving little time for preparation. In contrast, coronal mass ejections travel much slower, taking anywhere from several hours to a few days to reach Earth. This slower pace allows for more time to brace for their impact. ESA's continuous monitoring and advanced warning systems are essential in mitigating the effects of these solar events. By tracking solar flares and CMEs, scientists can provide timely alerts, helping to protect satellites, power grids, and other critical infrastructure from potential disruptions. While we cannot always predict the exact moment and strength of solar storms, vigilant monitoring and advanced forecasting by organizations like ESA enable us to anticipate and prepare for these powerful space weather events. This proactive approach helps minimize their impact on our technology-dependent world, ensuring that we are better equipped to handle the challenges posed by the sun's activity. How is Earth affected? Solar activity can have a range of effects on our planet and its technology. When the sun is particularly active, it emits electromagnetic radiation in the form of radio waves, X-rays, and ultraviolet light. This radiation can disrupt radio communications, especially on the side of Earth facing the sun, leading to temporary interference and signal degradation. In addition to electromagnetic radiation, the sun releases highly energetic particles during solar storms. These particles can penetrate the materials of spacecraft, potentially causing damage to their sensitive electronics and instruments. This poses a significant risk to satellites and space missions, which rely on their equipment functioning correctly to carry out their tasks. Another consequence of intense solar activity is the impact on Earth's magnetic environment. High-speed coronal mass ejections interact with the Earth's magnetosphere, inducing electric currents in long power lines and affecting the stability of power grids. This can lead to fluctuations in electrical systems and, in severe cases, power outages. One of the most visible effects of last storm was the dramatic increase in auroras. These beautiful light displays, typically seen near the polar regions, were observed at much lower latitudes than usual due to the heightened solar activity. The auroras extended across a broad range of latitudes, providing a spectacular visual display that captured the attention of many. As we continue to assess the impact of this exceptional solar storm, we are closely monitoring its effects on various technologies and infrastructures. We need to be in communication with Space Weather Service users to understand how they prepared for the event, how they managed the operations during the storm, and whether they experienced any adverse effects. Overall, while solar storms can create stunning natural phenomena like auroras, they also pose challenges to modern technology and infrastructure. Continued monitoring and preparedness are essential to minimize disruptions and ensure that we can effectively manage the impacts of space weather events. What will happen next? The solar region that caused the intense storm over the last May has now rotated out of Earth's line of sight, effectively moving us out of its immediate impact zone. Fortunately, we are no longer in the path of this particular solar activity. However, the sun is never static, and two new, highly active solar regions are currently coming into view. While precise predictions are challenging, these new active regions will be under close scrutiny by scientists. As these areas of the sun continue to develop, there is potential for additional space weather events. Monitoring these regions closely will help us anticipate any future solar storms and their possible effects on Earth. In parallel, the specialists are working diligently to document the impact of the recent storm on various technologies and infrastructure. This includes assessing any disruptions experienced by satellites, power grids, and communication systems. Understanding these effects is crucial for improving our ability to forecast and manage the consequences of such solar events. By analyzing the data from this and previous storms, researchers aim to refine predictive models and enhance our preparedness strategies. This ongoing work is essential for mitigating the impact of future solar storms on our technology-dependent world and ensuring that we can effectively respond to space weather challenges. As we move past this particular solar storm, our focus shifts to monitoring new active solar regions and assessing the impacts of recent events. Continued vigilance and research are key to staying ahead of solar activity and safeguarding our technological infrastructure from space weather disruptions. What is ESA doing about space weather? The European Space Agency is deeply involved in monitoring and understanding space weather through its Space Weather Office, which operates as part of the Space Safety Program. ESA's efforts focus on observing and predicting solar activity to manage potential hazards. ESA utilizes a range of missions to study the sun and its effects. These include the solar orbiter instruments, which provide critical data on solar activity. Additionally, other solar missions are being designed to help to understand how solar activity influences Earth's magnetosphere and atmosphere.